Welcome to this video from the Answers Diagnostic Report video series. This short video highlights common errors and misconceptions articulated in the calculus topic of the Diagnostic Report. The overall performance of the calculus section of the November 2023 matric exam had an average achievement of 50% countrywide. Question 8 is the second of 3 calculus questions in this exam, and it had an overall achievement of 47%. In question 8.1, learners had to determine the coordinates of the turning points of this function, and this question had an average achievement of 63%. And here is its memo. First, solving for the derivative equal to 0 to find the x values, and then substituting these to find their corresponding y values. And if we look at the common errors and misconceptions, some candidates did not realize that the function in question 8.1 was already factorized for them. They expanded the factors and equated to the left side. Instead of getting 0, they created another function. These candidates also solved for the x-intercepts rather than the x-coordinates of the turning points first. Also, in question 8.1, candidates did not equate the derivative to 0 explicitly. Some candidates only worked out the x values without calculating the corresponding y values. This led to an incorrect graph in question 8.2. Other candidates attempted to use the quadratic equation principle of x equals minus b over 2a to calculate the x-coordinate of the turning point, which does not lead to the correct answer in a cubic function. For question 8.2, learners had to draw graph F. This question had a 54% average achievement. And question 8.3, where they had to use the graph to determine values of k, this was not answered well with an average achievement of 18%. Here are the memos. You may want to pause here to have a longer look. The common errors and misconceptions for these questions are many candidates did not label the graph in question 8.2, even though it was explicitly asked of them to do so. Other candidates could not draw the cubic function and drew a version of a parabola. A common mistake was not indicating the y-intercept. And then in question 8.3, most candidates did not use graphical interpretation to answer this question, but rather used quadratic function theory and substituted in b squared minus 4ac, which was incorrect. Questions 8.4 and 8.5 both had an average achievement of 42%. In 8.4, learners had to determine the equation of g, and 8.5 was a nice integrated question where they had to find the value of theta. Here are the memos for these two questions. You're welcome to pause and take a moment here. If we look now at the common errors and misconceptions for these questions, in question 8.4, many candidates substituted into m equals change in y over change in x to calculate a gradient rather than using calculus methods to solve for the gradient. And for question 8.5, many candidates equated m equals tan theta, where the gradient they had calculated was a negative value. The link that the gradient was positive was not recognized by the candidates. The following are some suggestions for improvement for question 8. A. Learners should be taught to determine the properties of a graph from grade 10 to 12 in a progressive manner. The defining property of a turning point having a zero gradient is a way to describe a turning point. Teachers need to prove this link between the definition of a turning point and the grade 11 concept of determining the axis of symmetry to calculate the x-coordinate of the turning point. B. When teaching factorization of third-degree polynomials, teachers should include examples where there is only one real root. C. Teachers should continue to teach graphical interpretation in cubic graphs as a follow-on from the interpretation taught in grade 10 and 11. D. The concept of the point of inflection needs to be taught explicitly. And E. The application of calculus lends itself to many applications. Teachers need to expose learners to a wide variety of questions, which include integration of topics including analytical geometry, measurement, and trigonometry.
If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.